Hi, it's Dr. Andrew Padalano, and today we're going to go through an esterification with isoamyl alcohol and glacial acetic acid. So what we're going to start out with is a 125, or in this case a 100 milliliter round bottom flask, and we're going to put our starting materials in the flask. I'm going to actually put some gloves on first. Grab a couple gloves, should have done that before I started filming. Very important to make sure that you're always wearing gloves, working with organic chemicals. Some of them can go right through your skin, cause serious burns, any number of problems. Always consult the SDS before you start work. All right, so we're gonna start with some isopentyl alcohol, and what we're gonna do is we're gonna add, in this case, 15 milliliters of that to a round bottom flask. And I'm gonna grab one of these cork bottoms to hold it in place so it won't spill. So we have 15 milliliters here. And since we're not going to be pouring anything back into the glacial acetic acid, we're just going to reuse this graduated cylinder to transfer the glacial acetic acid as well. So we're going to need 21 milliliters of that. Now, glacial acetic acid is actually just pure anhydrous acetic acid. This one's totally fresh. I just took the seal off a few minutes ago. So I'll just measure out 21 mils into this container. So the graduated cylinder. You want to definitely keep this stuff in the hood. It will reek to high heaven. There we go. 21 milliliters. And then going to put that 21 milliliters right in there. This is what you would call a neat reaction, where you don't actually have any solvent. So generally you should always cover this container just because it's going to be pretty smelly on the way over to hood, the next hood. But once you get back to your next workstation, you're going to try to work with a low hood. But sorry, as I was saying, you have concentrated glacial acetic acid and isopentyl alcohol, and they're in pure form, mixing together and reacting in this solution. We're gonna add a catalytic amount of sulfuric acid to this mixture, but I'm gonna add that once everything's in place already. So we're gonna take this mantle, which is going to heat up. It's attached to a power source, and it's going to heat up slowly, but you always wanna make sure you turn it on last, right before you're really ready to go. So we're gonna just like set this in place first and grab the sulfuric acid. But you wanna always make sure that you take care of everything and make sure everything is secure before you actually begin the reaction. It's very important. Don't want to start anything prematurely. You also wanna make sure that your flask is pushing into the mantle to get good conduction of heat to the bottom of the flask. So we don't actually have a stir plate underneath this, but we do have boiling chips. So I'm gonna grab one of those in a second also. So it's just gonna create a little nucleation site for bubbles inside of the flask. Drop a couple of those in there. Don't need to be too precise with them. Also don't need to go overboard. That's fine. The big reason that you want to avoid water in your reagents in this particular reaction is that water is one of the products, and adding extra product is going to push towards the reactant side because it's an equilibrium-based reaction. So we decided we'll just go for the plain sulfuric acid. Won't be, it'll help. Push the reaction to the right. Just need a tiny little bit. So it's kind of syrupy. But it does look clean because it's nice and clear. And you don't want to spill this, it's quite concentrated. So what we're going to do is we're going to take 2 milliliters of this and pour it into this graduated cylinder. All right, so once we pour this in, probably not going to see anything crazy happen, but since it is a strong acid, and you always want to add acid to solutions, you don't ever know what's gonna happen and you want to go slowly. So just add a little bit of this and see if it does anything crazy, and then if it doesn't, then you can kind of move forward. Don't add anything too fast. Oh, and then instantly there, so the reaction was originally a light or a clear color, and as soon as I added all that sulfuric acid, it turned into a yellow color. So I flipped on the heat, and now that the heat's on, I'm going to actually take this condenser and throw it in place. And now I'm gonna check the clock and see exactly how much time we have before the reaction's over. So this is usually gonna go for 60 to 70 minutes. It's about, I mean, you can go as long as you want really, but we have about 9:45 on the clock. And so we'll put it at an hour. So about 10:45, we'll try to come check on this and work it up and move to the next step. And that's all we gotta do. It's gonna keep heating up and reach eventually a boil. If it doesn't reach a boil, you want to make sure that you turn the heat up as high as you can within reason, right? You want to make sure that you get it to a boil and sort of reach a reflux so that it actually is not going to go too crazy. So as soon as we let this start boiling hard, it started to boil so hard that the vapors were starting to condense at the very top of this condenser, which means that a lot of vapor was escaping. So in order to alleviate that and to prevent that from happening, we threw on the actual water cooling tubes. Always remember to put the input at the bottom, output at the top, and once it started actually flowing water, we saw the vapor starting to condense right here, which is just exactly where you want it. And you can tell that it's a reflux because when you look at it, you can see the drips coming back down at a steady rate. And that allows a lot of circulation for this flask, especially the bubbling will help mix everything and allow everything in equilibrium to get around and react evenly. All right, so time to stop this reaction. It's been a little bit over the time that I had hoped. It's about 11 o'clock now, so it's gone for about an hour and 15 minutes. It doesn't really matter here. The longer you run it, hypothetically, the better. What we're gonna do is we're just gonna power off the mantle, and we're going to allow it to stop boiling. One thing that is a good way to allow it to cool a little faster is to lift this up, and if you're already clamping this neck, you want to make sure it's nice and tight. As long as it's cool enough, you can lift up the flask, and you can remove the mantle carefully. Always want to work slow. No point in moving fast here at all. It's better to work slow and carefully if you ever can. And the nice thing about this arrangement is if you leave the water on the condenser, it'll slowly, not extremely effectively, but slowly remove some of the extra temperature from the flask on the bottom. Already it's not boiling anymore. You want to let it cool down a little bit because this mantle is quite hot before you put it into the ice and get it down to room temperature. All right, so when it comes to dismantling this, what you're gonna do is you're gonna turn off the water. You don't want to accidentally knock the tubing out and get water everywhere. That can be really disastrous. We're gonna pull out the condenser, lay it down softly. We can deal with that later. We just wanna make sure it's nice and stable. And we're going to carefully remove this flask. So it's pretty hot. You might want to use a hot glove if you're not as used to handling hot stuff. And I'm going to slowly place it inside this dish. So one thing about this too is you don't want any of this water to get in there. You don't want any water to actually get into your product. So you want to make sure that you don't allow it to fall over and tip into the ice. One thing I'll do to make sure that that doesn't happen is I'll throw a little bit extra ice into the dish just to make it nice and cozy. Another thing that will speed up the cooling process is to begin by adding our 10 milliliters of water. Or sorry, in this case, you would be normally using 10 milliliters of water, but we tripled all the reagents, so it's going to be 30 milliliters of water in this case. All right, so I'm going to stir this around a little bit. Put a little bit of water in here. And the steam that came off of that was from the acid. I'll let it sit for a second. Sometimes if you're not getting great conduction of the cold into your flask, you can just add a little bit of water, and that'll allow more of the heat to get sucked away quickly. Mostly you want to reach about room temperature here. All right, so now we're going to put all of this into our separatory funnel. Already you can see 2 layers forming. Make sure that this is closed before you pour it anywhere. That's very important. You also want to do your best to decant the solution off of the boiling stones. You don't want any of those being transferred over. They're probably potentially going to clog your stopcock, and that is no good. No fun. All right, I'm going to take a little bit extra water, give this a rinse to make sure we get everything over, and pour it in. All right, so now we're just going to throw this to the side. This is kind of cooled down a little bit, so you can just kind of leave this on top of here. We'll clean that later. Not very, as long as it's out of the way, it's not going to hurt anything, that's fine. You can also, if you make this mistake, or if you mix them up, as long as you keep the layers separate, you can always figure out which is which. And we're going to add an aqueous solution in a second, so if it all mixes together, you know you just mix aqueous with aqueous also. There we go. And then now, we're going to keep this organic layer in place, and we're going to throw the bicarbonate in there. So the bicarbonate is going to actually remove any extra acid that's left over. So let's take some of this bicarbonate. Sodium carbonate would work well also. We're going to form H2O and CO2 from any extra acid in solution. And we're going to need, in this case, 15 milliliters, so we'll use the same graduated cylinder. There we go. Perfect. And mix these together. So we know that we actually selected the right layer as the organic layer automatically, because you can see not only has it formed 2 phases instead of 1 phase as you'd expect if it was all aqueous, but you see it mingling with the acetic acid, which is going to be protonated, that's left over in the organic layer on top. And that's why it's bubbling. So if you look closely, you'll actually see this bubbling, and that is the formation of CO2 and H2O from the bicarbonate. which will leave behind sodium acetate, which will preferentially move to the aqueous phase also. So the right way to actually work with a separatory funnel, by the way, once you let it gas off a lot of the way, because you don't want to have any pressure building up too much, you will always shake and release. Shake and release the gas. It's important to do it very often for this one because it's a gas forming reaction. And once the gas subsides, you know that you've neutralized all of that acid. Or you've used up your neutralizer and you actually need to add more. But we'll find out soon enough. It's actually cleaned up the organic layer pretty well. Don't forget to take the stopper off the top as well. There we go. Rookie mistake there. So you want to get rid of this aqueous layer on the bottom again. And it looks like it's a little cleaner in here too, which is nice. Got to lighten the color a little bit. Got a little bit extra, it doesn't really hurt that much. This is going to further exacerbate the ionic qualities of the water, and that difference with the qualities of the organic phase, which is not going to be charged. So you should always off-gas any of these separatory funnels while you're shaking them. Make sure that you put your hand firmly against the stopper so that you don't have any leaks also. Very important there. Otherwise you're going to feel your hand start to, it's like, oh, it feels like there's some kind of wet solvent dripping out of my hand. Obviously not very safe. Cool. And we're going to let the separation happen with 2 layers. Take off the lid of the stopper. And we will dispense the aqueous layer. In order to make this as dry as possible, I usually end up maybe sacrificing a tiny bit of the organic layer just to get rid of all the extra water. And now we begin the drying process. So in order to dry this, what we're going to do is we're going to take a nice flat beaker or flat bottom beaker and drop this product into that beaker. So this is our organic layer, mind you, and so it's going to resist any kind of dissolution of water. Water is not going to be very soluble in it, that's why we had 2 phases, but there will be some water in it. And so we're going to add a little bit of sodium sulfate in order to dry the product. So I'm going to just grab a spatula. And then we're going to take a little of the sodium sulfate. Ooh, it's a fresh one. It's fresh. Very nice. Na2SO4. Yeah, so the sulfate is going to be great at pulling water out of this. So you just want to add enough. And how much is enough, right? A couple good scoops is a good place to start for this much product. Maybe 1 scoop if you were using it on the original scale. And what you want to look for is you want to see it act like a snow globe. You want it to not be clumping so much. So sodium sulfate, you technically need to wait a little bit longer and allow it to properly soak up all of the water. But this one's kind of clumping a bit more than I'd like, so I'm going to add a little bit more of the sodium sulfate. The more clumpy it gets, that's usually a sign that you're going to have some kind of extra water in there. It's always better to make sure your product is dry and free of water than to worry about wasting too much sodium sulfate. It's pretty cheap stuff usually. So higher quality product is ideal. So if you can look at this, which is harder to do from the camera angle, what I can see from the top here is a lot more of the individual small granules are not clumping up so much. And that's a good sign that you're not having a whole lot of extra water interacting with that sodium sulfate. So that means that you're pretty much ready to go because you're dry. So what we're going to do next is I'm going to take a filter paper. So I'm going to grab one of those from over here. And we're going to take this filter paper, we're going to fold it into just a gravity filter. So what we're going to do is first fold it in half. Fold it into quarters. And then we're going to open one of the far sides and we're going to crease it into a square and open it up. This creates a nice simple funnel, works every single time. You can get fancy pre-made fluted funnels, kind of extra money, doesn't really help that much, but convenient. I'm going to toss that right here. I made sure ahead of time that this was a clean beaker, and I will place a gravity filter so that I can take this product and remove all the sodium sulfate from it through gravity filtration. I pre-weighed this flask so that I can actually just take whatever mass of the product ends up inside of here and calculate that later. So what you can do also to find the boiling point and to further purify this substance to make sure that it is what we hope it is you could technically take it and distill it over and purify the isoamyl that way, and that'll leave behind a lot of the colored impurities, which come from usually ionic compounds that are in solution. Unless the organic molecule has a colored quality to it in its pure form, which it depends on the certain organic compound that you're working with. But for now, in order to get this dried out version of our product, which is going to be the isoamyl acetate, we're going to just pour it through this gravity filter and allow it to drain into this container. Another quality of this particular product that is very easy to distinguish the successful synthesis from is the smell. This smells like bananas. Really, really a lot like bananas. Very strong odor, and that's typically the main smell that bananas give. Like when we think about what a banana is, this is the odor compound that gives us that smell. And it smells pretty potent, even with the hood. So typically if you were going to, let's say, evaluate that by yourself, you want to make sure that you waft it and you don't actually breathe it in directly. So what I'll do is just waft it. And it is like runts, basically. It smells very potent. So in order to actually figure out what the mass of this product is, which you'd expect to be a liquid, we're going to bring it over to the scale and see what we get. So 78 grams. I'm going to leave that there and record that mass. So it turns out that that's almost exactly, actually a little bit over 10 grams of product, 10.04 grams that we produced there. So for your actual yield, make sure you keep that in mind. Hey there, this is Andrew Padulano, Dr. Andrew Padulano. I'm going to start over again, okay?